So we're going to talk about compressed air systems now, and I'm going to take you through a specific analytic that was developed to help optimize a compressed air system with regards to staging and sharing of load. So just quickly, on the left-hand side of the screen, you can see a couple of different components within a compressed air system. Of course, the group of compressors itself, individual air compressors, filters, but we've also developed analytics for other types of equipment within the plant, specifically dryers, flow meters, and then also on the demand side, distribution system of the compressed air system. So today we'll focus in on the actual air compressor group, specifically 100-pound compressed air system. And you can see that there's a number of different analytics deployed on this specific system. One finding that's coming up is that more compressors were operating than needed. Of course, the staging optimization analytic, cooling water temperature not meeting set point, and pressure control analytics around reducing discharge pressure off the compressors whenever possible. But I want to focus in specifically on this staging optimization analytics. So we'll double-click on the analytics specifically, and we're taken to, again, the analytics performance dashboard to get a little more context around the issue. And so the way that this staging optimization analytic actually works is that each compressor, its manufacturer's performance curve is essentially inputted into the system, into the FacilityConneX configuration, so that you can develop a model of each individual compressor. And in a real-time basis, the analytic works to determine the level of load that each compressor should be handling to minimize the total energy consumption within the plant. So some facilities may actually already have a staging optimization or control system that's intended to minimize energy consumption. And in that case, this analytic is really acting as a check. It's determining whether or not that sequence or that controller is working as intended. In many cases, things can be overridden. Set points within that algorithm or sequence can be changed by operators. And this analytic is really meant to detect those deviations and help red flag them, determine what the energy savings might be associated with correcting the issue and getting it fixed as soon as possible, since air compressors are a huge source of energy consumption within any facility that has a plant. Now, if the compressed air system does not have a automated control system or optimization algorithm built in, then this is really helping you understand what the return on investment might be by switching to one of those controllers or systems within the plant. And so you can see here that within the transitions dashboard, which I'll increase in size to help see it, each time the analytic executes and develops a new optimization finding, a specific recommendation for how each compressor within the plant should share load is provided. So you can see here on the second line that during this specific instance of an issue occurring, the algorithm determined that two of the compressors should be loaded approximately to 3,500 CFM, and the first compressor should act as the trim machine. And in this case specifically, it's known that those two compressors are actually centrifugal compressors, which are more efficient than the trim machine in this plant, which is a rotary screw machine that operates load and unload. So the algorithm is telling the operator that you should base load the two centrifugals that are necessary to meet the current load within the plant, and to trim with your load-unload screw, which is a very conventional way of operating a plant very efficiently. Now, if we move over to the trending capabilities, we can trend a variety of different points, which will help us better understand this recommendation. You can trend the power consumption of each compressor, the actual recommended or calculated power consumption if the system was optimized. And you can look at a variety of other parameters that help drive you to help understand the recommendation that's being made. And since air compressors, as I mentioned, are such a huge energy user within most buildings, This one analytic alone could offer tens of thousands or even hundreds of thousands of dollars in annual energy savings in a large plant that is not well controlled. Many times large compressed air plants are actually operated manually using an operator that may or may not be there 24 hours a day. So this really provides you the tools that you need to help either implement a optimization control strategy or to ensure that that type of system, if installed, is working effectively and has not been overridden and it continues to perform as it's intended.